Alright, so we're going to talk about the combined gas law and work some problems to make sure that we can understand what's going on here. Remember, pressure times volume divided by temperature of one condition equals your pressure times volume divided by temperature in your second condition. So what we're going to do is we're going to start with the word problem. We're going to pull out the information as we get to it in the word problem. Okay? So let's go ahead and do that. We say a gas is at 5 degrees Celsius. Well, the degrees Celsius tells us that that's temperature. So our temperature is 5.0 degrees Celsius. It occupies, our units here are liters, so that tells us its volume. Our volume is 3.12 liters at, and we've got atmospheres. Atmospheres tells us its pressure. 5.00 atmospheres. What is the temperature? So we know something's changed. We've got a second condition, and it's asking for what that temperature is. When the gas has a volume of 1.32 liters at atmospheres tells us its pressure, 1.00 atmospheres. Okay. So we've got two conditions. We've been working with pressure, volume, and temperature. So we know we need the combined gas law. All three variables are changing. No other gas law is going to work. Okay. So let's go ahead and write our combined gas law. Pressure 1, volume 1 over temperature 1 equals pressure 2, volume 2 over temperature 2. So let's identify which thing that we're actually looking for. We're looking for T2. So we need to solve this algebra problem for T2. Now we have a little bit of an issue here. T2 is in the denominator. We cannot solve for it when it's in the denominator. We need to get it to the numerator first. So how are we going to get that guy to the numerator? Well, we're going to multiply both sides by T2. That's going to get it up to the top. If we do something to one side, we have to do the same thing to the other side. Okay. The T2 on the bottom cancels out the T2 on the top. And we end up with T2 P1 V1 over T1 equaling P2 V2. Now we're still looking for that T2, but now it's in the top. Now it's in the numerator. So now we can solve for it. We have to get everything else to the other side. And we can do that by, let's get T1 to the other side first. Okay, we can multiply this by T1 so that they cancel out. If you do it to one side, you have to do it to the other side. So we end up with T2 times P1 V1 equals P2 V2 times T1. This is all algebra. We're just solving for that variable. Now we've got to get T2 by itself, so we're going to divide through and get rid of these guys. Divide through by P1 V1. If you do it to that side, you have to do it to this side. P1 V1. These guys cancel out. And so we're left with the fact that T2 is going to equal P2 V2 times T1 divided by P1 V1. Okay, so I just recopy that down here. Alright, now we've actually solved for that T2, so we can plug in our values. Be careful, you want to get the right values in the right place. Now before we plug them in, we should notice that we are talking about gas laws. Gas laws require all temperatures to be in Kelvin. So right away, before we plug anything in, let's add 273.14 to that degrees Celsius, and we're going to get 278.1 Kelvin. Okay, So that's the temperature we're going to use for T1. Do note that we're calculating with significant figures there. So let's go ahead and take our equation, and we will plug all the numbers in. P2, that's the one down here, is 1.00 atmospheres. V2 is up here, 1.32 liters. Now be careful, this is T1. This is probably the biggest mistake I have people do, is they're not watching their subscripts. T1 is the number up here, so it's 278.1 K. And then we're going to divide all of that by pressure 1, which is our 5.00 atmospheres, and our V1, 3.12 liters. Now before we pick up our calculator and do that math, we're going to check our units, because remember, the units can actually save us if we make a mistake. So atmospheres cancel out with atmospheres, liters with liters. The only unit we didn't cancel out is Kelvin. So that's what our answer is going to be. Is Kelvin a valid unit for temperature? Well, yes it is. So we know we're on the right track when those units agree. So let's go ahead and type this into our calculator. And we get 23.5315. And before we move on to the next problem, we've got to look at significant figures. We had 3, 3, 3, 3, and 3. So, excuse me, that one's 4. So our smallest number is 3. We need 3 significant figures. So 1, 2, 3. We look next door to see if we round. This is a 3. It's under 5, so we're going to round down. So we're going to have 23.5 K. There's our final answer. So we had to use the combined gas law because we're changing all 3 variables. So we absolutely have to use the combined gas law. Let's look at another one where you've got a gas law problem. And this time we're going to use the combined gas law. Okay. So let's go ahead and look at this one. We've got a gas that occupies, again, it's liters, so it tells us that it's volume. So the volume is going to be 3.00 liters. And the atmospheres here tells us its pressure. So 2.00 atmospheres. And it says calculate the volume. So we know something's changed, and it's the second volume that we want when the pressure is. So our pressure is changed to the 10.15 atmospheres. Okay. Now we're going to use the combined gas law to solve this problem. So we've got pressure 1, volume 1 over temperature 1 equals pressure 2, volume 2 over temperature 2. Now we're going to look at the data that we have. We have no temperature mentioned. If temperature is not mentioned in the problem, we assume that it's constant. So if it's constant, it just drops out and cancels out of the problem. So we get P1V1 equals P2V2. That's basically Boyle's law, right? So whether you started with the combined gas law or whether you started directly with Boyle's law, you should get the same answers. So let's look at what we're solving for. We need to solve for V2, this guy right there. So how would you solve for V2? Well, we're going to divide both sides by P2. You do it to one side, you got to do it to the other side. These guys cancel out. And so we've got V2 equals our P1 V1 over P2. Now that we've got solved for what we're looking for, let's plug things in. Pressure 1 is up here, 2.00 atmospheres, times volume 1, 3.00 liters, divided by P2, which is our 10.15 atmospheres. Check our units. Atmospheres cancel out with atmospheres. The only unit left that we didn't cancel out is liters. Is liters a valid unit for volume? Yes, it is. So we know we're on the right track. Then we can take our calculator, and we can plug it into our calculator. And we get 0.59113 on our calculator. Of course, we have to look at significant figures before we move on. 3 significant figures. 3 significant figures. 4 significant figures. 3, 3, and 4. Which one's smaller? 3. So we need 3 significant figures here for our answer. So let's go ahead and look at that. We've got 1 here, 2 here, 3 here. We go to the guy next door to see if we round up or down. It's a 1, so we're rounding down. So our final answer gets to be 0.591 liters. So hopefully from these examples you've seen combined gas law is the most important gas law that we've talked about so far, because you can use it when all 3 things change, or you can use it in other situations where you only have 2 of the things changing. But the combined gas law can be used in both cases. Okay, so do make sure you memorize that and can use it as you're going through your problems.